10.4, we're going to talk about measure of central tendency, that is how data values sort of bunch up. And then variation, which is how they are spread apart. Okay? So we're looking for where their center tends to be and how spread apart they are. The first one we're going to talk about is central tendency, that's the bunching up. This is represented whenever you hear the word average. Now, most of the time when you hear the word average, you mean the first one, which is the mean. An arithmetic mean is the average, you see the quotes, of the values found by adding the values together and dividing by the total number of values. And this is what you do when you calculate your grade in my class, right on Jupiter. It's what you do when you calculate your GPA. It's the one that you tend to mean when you say average. When you add things up and you divide by 10, whatever, you divide by something. A median is a middle value. So it's found by taking all the data values and putting them in order from smallest to largest. So imagine if you guys were to all stand up and we were going to put the shortest person over here and the tallest person over here, and we just counted off one by one until we got to the person in the middle. Now, we have an even number of people in the classroom today, so that makes things a little bit awkward. If the two people in the middle happen to be the same height, fabulous, we've got their height, it's the same. If the two people or the two values in the middle are not the same, then we actually do the average, like the mean, of those two values, and call that the middle value. Okay, can you picture doing that? Okay. This is the kind of thing that some people will say. I had a student come in my office, and it wasn't my class she was asking questions about, but I know her outside of my class, and she was having some difficulty with Jupiter, and she said, I don't understand why my grade is whatever it is. If I look on here, I see that I have mostly A's. So why do I have a C in the course? You guys probably had similar experiences, right? Well, because all the things she got A's on were the things that weren't weighted as heavily, correct? The things that she was doing poorly on were the things that cost her more points. So she was in her mind doing something like this. She was saying, well, most of them, in fact, she was doing even more about the mode than she was with the median. Yeah, but she was saying, if I were to put them in order, I'm getting, mostly A's. What's going on here? And we looked at it more carefully. The mode actually is exactly what she was doing, which is she was saying, well, it occurs the most, so that's the grade I should get. Or at least that's the grade she was expecting that she was getting. So the mode is the value that occurs most frequently. So for instance, let's say that you wanted to find the average salary of the people who work at Sonic. Well, if you wanted to do that, you could do that in any of these three ways. All right, so one thing you could do is you could add all their salaries together, divide by the number of people who work there, find out their average salary as a mean. You could put their salaries in order on paper, right, from smallest to largest, and find the one that was in the middle and say that's the average, or the median. The other thing you could do is you could look at them and say, well, but the majority of the people there make, $8 an hour or whatever. But things get a little bit skewed when you start throwing in the CEO of the company, right? I mean, we don't really mean him when we're talking about these averages. Do you follow? So there's different reasons why you might want to do this, right? So if you're talking about the average house price, I don't want the $6 million house thrown in with the rest of them, because it's going to make it look weird. I mean, most of the houses aren't the $1 $6 million house that happens to be in town. I don't really want to look at that one. So sometimes it's more reasonable to look at one of the different values. All right, so we're going to use some real small data sets so we can do these and do them by hand first. So we're going to find the mean, the median, and the mode for the numbers. So to find the mean, what do I do? Right, so what do I want you to show me? I either want you to show me the written down addition of all of them. So in this case, that'd be 18 plus 22. How many of them are there? There are 7. So you can show me that step. I'm okay with that. Or if you just want to add them all on your calculator and show me the next step that I'm going to show you, that's okay with me too. What's the top? 135? 139. 139. So you have to show me one of those two steps. You don't have to show me both. You show me one or the other. That way if you've got an error, I know where it happened and I can say, oh, you forgot something you had. Oh, look, you missed that 17 or whatever. You figure out what your error is, okay? And then you're going to actually find the value, and we're going to go with one decimal place in all these. 19.9. So the mean is 19.9. What do I do to find median? Put them all in order. And you can go either least to greatest or greatest to least. It doesn't matter. I tend to go least to greatest. So what's my smallest value? 12.
17. 18. 22. 22.
Oh, 22s. Okay, do I have them all?
30.
Oh, one more, 30. All right, so on this one, you can probably recognize we already found out that there were 7, or you can actually count your way in, right? So if you want to count your way in, we can mark off the 12 and the 30, and then you can mark off the 17 and the 22, the 18 and the 22, and lo and behold, in the middle is the 18. Okay. Now let's just say for a moment, let's pretend that the 12 was not in the data set. If I did the same thing, the 18 and the 22 here would both be in the middle, and then what would I do?
Divide by 2.
Add them together, divide by 2, and I'd end up with 20. Good. All right, the last one is the mode, and what do you notice about mode for this one?
There's 2 numbers.
There's 2 of them, and that is perfectly fine. You can have more than one mode. So the mode would be 18 and 22. So this is actually what we call bimodal, not to be confused with bipolar. Binodal, and you can have multiple ones. It doesn't just have to be 2, so there could be 3 or 4, whatever. Let's just say for a minute, though, that there were nothing that had more than the rest, or maybe all of them had 2 of them, like they were all in doubles, or nothing was repeated more than once, or something like that. If that's the case, we say it has no mode. Make sense? Nothing occurs most frequently because they all occur the same number of times. All right, so let's take some examples of questions that take this idea and actually use it in problem solving. All right? So example number 2 says, the mean score on a test of 20 tests is 75. What is the sum of the 20 test scores? So can anybody tell me what you think you might do for that? You will. But do you know why? Like, you said of why that would work for me, Kayla?
Well, if it's the average, then you have some people that made less, and you have some people that made more, so they kind of balance each other
True.
out. So if you times it by how many scores there are, then you can.
Yes, and you're 100% correct, Kayla. I'm just not trying to get you to say what I want you to say. So let me just go here. It's okay. It's okay. You're right. I just want to make sure that everybody sees why that's going to work. All right. When we found the mean before, what did we do? What's on the top? The sum, right? What's on bottom? In the number of values. And what does this equal? The mean, or the average, right? So if you take that perspective on the next slide, and you were to do the same thing, this is the sum over n for the number of values, and that gives you the average, or the mean. We can think about it from this perspective again, right? So the sum is what we're actually looking for, correct? What is the sum? We know the number of test values. How many tests were there? 20. And we know the test average was a 75, right? So the reason that what Kayla was suggesting will work is because you're using that same setup, and I can actually then take the 20 and multiply it to the other side with the 75. Does that make sense? Because some of the questions you get are going to be a little bit trickier on how they're worded, but they have this same process involved. So what is 75 times 20? 1,500? So see 1,500, and there are points on this particular problem, right? Number of points. So example 3 is another one of this sort of variety. It tells us the mean weight of the 7 linesmen on a team is 230 pounds. The mean weight of the 4 backfield members is 190 pounds. And we want to know what is the mean weight of the 11-person team. So what might come to your mind is you might think, oh, well, I've got 2 values, 230 and 190. I add them together and divide by 2. And that would work if what were the truth?
There was like 7 linesmen and 7 back.
If there were the same number of each of those weighted groups. But there's not, right? And this is exactly what was going on when my friend came in and was asking me questions about her grade. Things were not equally weighted, so that's why she was confused on how it was appearing inside of her grade, right? So what do we do? Well, we're actually going to do what we did on example 2, but we're going to go a step further. So what did we do to find out the actual sum of the points of those tests?
Sum over.
And that gave us this multiplication feature that we were talking about, right? We ended up multiplying. We can do the same thing here. We've got 7 linesmen, and their average weight is 230 pounds. So what if I actually were to find out their actual weight? How can I do that? Right. I have our 7 people. Their average weight is 230 pounds. This would actually tell me how much they actually weigh if I added their weights all together. And then, oh, what did you get, Kayla?
16.
Okay, we'll get there in a second. But that's not the only people on the team, right? We also have 4 backfield members. And so what am I going to do for those guys?
Plus 4 times.
Okay, so I've got the 7 people represented whose average weight is 230. I've got the 4 people represented whose average weight is 190. Now what? Yeah, divide by 11 because there's 11 people. All right, so Kayla, you said this was 1610 at the beginning?
And plus 760.
All right, so what's 1610 plus 760? 2370, and then divide by 11?
215.
Pounds, thank you. Make sure you label what you found, 215 pounds. Now, a good thing to do at this point would be to take a look and make sure that that value we just got was between the 2 values we started with. Because if we're averaging them together, it better be. And 215 is between the 230 and the 190, so this is a reasonable solution. If you had done this and made some sort of an error and you found out that it was 250 pounds, there's definitely a problem, right? You can average things together and get them larger than what you started with. Okay, I think we're going to stop there because that breaks the section in half. We have central tendency, and then the next section is actually about variation. So we'll come to that next time.